Okay, we're back doing some complex Sudoku. We're doing a 2-star puzzle, because my monkey brain cannot handle anything besides 1 or 2 stars on Logic Masters Germany. Here are the rules. Normal Sudoku rules apply. That means the digits 1 through 9 must appear once each in every row, column, and 3x3 box. Digits cannot repeat on the indicated diagonal. I see, so that's this diagonal right here. Let me get this correct. We're just adding an additional rule to Sudoku here, which is that this diagonal must also be the numbers 1 through 9 once each, on this diagonal only. Digits along blue lines have the same sum within each 3x3 box the line enters. Okay. So you can see, look at this blue line, for example. You can see it actually enters 2 3x3 boxes. It's in this box, and it's in this box. So this, for example, could be 9, and this could be 5 and 4, because this adds up to 9, and this adds up to 9. Digits in cells with a shaded square must be even. Looks like it's just that cell. And digits in cells with a shaded circle must be odd. Looks like it's those cells. And that's all the rules. The puzzle is Forgiven by James Sinclair. Link is in the description if you want to give it a shot. Now I'm going to try. And I've never really done a region sum puzzle like this before, so it's going to be interesting for me. This constraint means that this square... Actually, it doesn't change anything, because this 4 is basically the same. So we know that this 4, or rather this square, is either 2, 6, or 8, because this is an even cell. And then, of course, these circles would be 1, 3, 5, 7, and 9. I'm not going to write these in, because that's a few too many numbers for my liking. And something that stands out to me right away are these blue lines that have 3 in one box. Because what this means is, the minimum that you can make these is 1, 2, and 3, which is 6, which means that these guys that are living on their own on the outside must be a minimum of 6. I don't think that this is super important, but there's also something interesting here, which is that obviously these must be the same, because they sum to the same number, which therefore means these two cannot be the same as those yellows, because this is seeing. So these have to be a different total. These also have to be a different total, but I don't know if they have to be different from these pinks. And then it's the same thing here as well. Okay, there is one deduction we can make here, which is that these can't be 7, because the only way you can make 7 with 3 squares is 1, 2, and 4, and we already have 4 in here. These can't be 7. Oh, okay, again, I don't know if this is the break-in, but I'm seeing something here, which is that, let's look at these two, right? Let's look at what, like, when we put the number in, what are those numbers seeing? Well, they see this row, this column, and this box, because of this number. And it's seeing this column, this row, and this box, because of this number. Now, where does that number go in box 1? Well, it can't go on the same line, otherwise the sums wouldn't work. Which means that this number is the only, or this cell is the only cell left that this number could go in. So all 3 of these numbers are the same, which means this cannot be 2. And it also means that these are not 9, because these are all the same. And here's the thing with 6 and 8. The only way to make 6 is 1, 2, and 3 in this box. And the only ways to make 8 are 1, 2, and 5, and 1, 3, and 4. Well, it can't be 1, 3, and 4. Therefore, this is either 1, 2, 3, or 1, 2, 5. And 1, 2 is definitely somewhere in these 3 spots. Yeah, and it's the same situation down here, right? Whatever these 2 cells are, you see, there's only 4 possible cells in this square. But it can't be these 3. So it has to be this one. So these ones are the same. Actually, I'll make them a different color. Now, the problem is we were able to reduce these down because we knew that this one was even. In this case, we don't actually know what these are. But we will know, like, once we figure out this one, if we know this is a 6, then we know that these also are not 6, because this is on the diagonal. Okay, I almost thought I was onto something here. So what I currently have highlighted, let's just put it in gray for now. All of these are what the 3 green squares up here are currently seeing, right? So if these are all 6, this is what the 6s are seeing. That means where can this green cell go in all of the other boxes? Well, there's 2 options here, 3 options here, etc. And I was thinking, well, it can't be this one, because we know this one is odd, and the green cell is even. So this is gray. And I was about to say that it also cannot be this. But unfortunately, I think it can be. Because if this is 6, if these are 6s, this can be 6, 1, and 2. And then these would equal 9. Which is totally allowed. So if this is an 8, like if these are 8s, then we know that it can't be here, and then the 8 must go here, right? So it's being a little pesky. But I'm wondering if I'm onto something here. Ah, I see. These cannot be green or yellow, because green and yellow are seeing these. So these are a different number. And the same goes for these. Now, could these also be pink? Yeah, I think they absolutely could be pink. So these could be the same numbers as these. I won't lie, I've been sitting here for a while just looking at this. I'm not entirely sure where I'm supposed to go next. Oh, was I on the right track here? Hold on, if this is 6, then this has to be 1 and 2. Yeah, that's totally fine, because this can still be 1, 2, and 3, like this. Yeah, and also we can do it over here as well. 6, 1, 2, and 3. Or, well, that doesn't have to be anything. Okay, so that doesn't work. Okay, I found something kinda interesting by just following the same logic I was doing with these green cells, but instead with these pink cells. So if we take away all of the stuff that the pink cells cannot be, if we're trying to find out where else the pink goes. There we go, we filtered out the rows and the boxes and the columns. And now my question is, where can the pink go on this big old diagonal line? Well, it can't go on these two, because we know what those are. It can't go on this one, because this is on the same region sum line. So you can't have, like, both 8 and 8 here. And we know that the pink and the yellow cells are different. So that means this one is pink. I don't know if that tells us anything, to be honest, but I just saw that. You know, I think one thing it tells us is we have 6, 7, 8, and 9 on these 3 squares. Where does the other one go? Where's the 4th square? And I think it has to be one of these two. Oh, and that is kind of interesting, isn't it? Hold on, we're seeing something here. So 6, 7, 8, and 9, right? Are high numbers on this diagonal. Oops. Right now, we know where 3 of them are. They're here, here, and here. Now, we know that they can't be on this one, because... Oh, actually, could it be? Yeah, because if this is 9... Oh, no, because this has to be a sum that is smaller than this one. Oh, yeah, well, this could be a 9, though. This could be a 6 and a 3. So, actually, it could be there. Okay, never mind. My revelation has evaporated. But look, this has to be pink now, right? Because these can't be pink. So this has to be pink. Oh, and then this has to be pink? Certainly seems like it, doesn't it? Oh, okay, so what I've just done is I've filled in all of the squares that the pink cells are currently seeing, right? So every row, column, and box that the pink cells are seeing. And what's interesting here is obviously we're left with, you know, a lot of spaces where pink could go. Okay, and so what I'm seeing here is, you know, pink has to go somewhere in this middle box. It has to be one of these 3 squares. Well, if pink is in any one of these spots, then that means this cell is seeing it. Or if it's in this spot, this cell is seeing it. Or if it's in this spot, both are seeing it. Which means that these ones cannot be pink. We also know that they can't be yellow because of this, and they can't be green because of this. Therefore, these are a different color. I don't like red. Blue? Yeah, blue is fine. And that's mighty interesting, right? Because now we have 4 different colors for our top 4 numbers. And I suspect this is going to give us some momentum. Yeah, right away, look at this. This is all the areas that blue is currently seeing. Where does blue go on the diagonal? On the big diagonal that we got? Well, it's not pink and yellow, it's not green, and it's not 4. Therefore, this must be our blue. Look again. In the top box up here, we can put a blue. I'm just going to keep doing this, man. Oh, whoops. I made a mistake. Well, I just put 2 blues in the same box. What am I doing? Okay, I suspect that doing more coloring here... Like, I've just done a lot of variations of, like, filling in the grid to see where these colors must go. And I suspect I'm at my limit now. I didn't find anything else. And I think it has something to do with, like... We know that green is 6 or 8. So is there a situation in which... When we use a green, it cannot be 6 or 8. I'm not sure yet. Well, I have to take a break for now. I'm going to leave it here. Let's take a look at it later. Okay, it's a new day. I'm taking a look at this again. Let's see how it goes. Right, and I think I'm seeing something right off the bat here. And that's the cells that I've highlighted. Where does yellow go in box 5? Well, yellow cannot go in the boxes I've highlighted here. Yellow must go on this Renban. And that's very interesting, right? Because that means 9 could not go on this, because there's no sum that you can make here that would equal 1 digit. That means yellow is not 9. Now, it could be 8 and 1, 7 and 2, or 6 and 3. Or 6 and 1, or whatever combination of those. Oh yes, and there's another very obvious thing that I think I've missed, and I've been staring at this puzzle for a long time, the last time I was recording, and I couldn't find where was I supposed to look. And something that I think I overlooked pretty quickly was the fact that blue is on the same line as this pink, which is very important, right? Because that means that this blue, in combination with another number, needs to be lower than these pinks. And that means that blue cannot be 9 either. Now, you still could have 8 and 1 here, and you could have 3 numbers adding up to 9 here, and have these be 9. But we have discovered something important, which is that we have 4 colors here, all indicating the top 4 numbers in a valid Sudoku, 6, 7, 8, and 9. And 9 can only be in pink. You can't put it in blue, because we just proved that. Can't put it in yellow, because we just proved that. And we already knew that it wasn't green. So 9 must be pink, which means we've just got a lot of digits. Now, I suspect that this is going to do a lot for us. We just put 5 digits into the puzzle at once. For example, where does 9 go in this box? Not here or here or here, and it can't be here because of the blue line. So 9 is in one of these 2 spots. Oh, I suppose we should also be looking at this line as well, because this is either 6 and 3, 7 and 2, or 8 and 1, which doesn't really constrain anything. And then in here, it gets very interesting. The question is, can 6 be here? If this is a 6. Obviously, if green is here, it can't be 8. It has to be 6. So if 6 is here, we can do 6, 1, and 2. So these would have to be, like, let's say this is 6. These would have to be a 1, 2 pair. And then that would force 1 and 2 to go here, like that. And then this would be either 3 or 5. Is there any problem with this scenario? I don't currently see a problem with this scenario. So this is valid. So green is still in one of these 2 spots. And is it the same situation here? No, I don't think it is. Because, again, if green is in one of these 2 spots, it cannot be 8. And if 6 is in one of these 2 spots, you need to have 1, 2. Those are the next 2 lowest possible numbers. But this equals 9, and we know that blue is not 9. So actually 6 or 8 cannot be on these spots, which means this is green. Not that I think that does very much for us. We do have something interesting, though, which is where does 9 go in row 3? Well, it's not here, 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 anywhere here, because we see it all in the columns. It can't be on here, because you can't put 9 on a blue line where the end goal is a blue shaded cell, so it can't go here either. So there's only 1 spot left. This must be 9. Now, unfortunately, this is not really that constrained, I think. So I don't think it's going to help us that much. We're able to place another 9 here, because by Sudoku, it can't go here or here, so it must go here. 9 in one of these 2 spots. Oh, 9 can... Oh, so 9 has to go... Okay, so we have our 9s. It's nice to have all the 9s, but I don't know how much it's really helping us. Okay, does yellow have to be up here now? If yellow is 8 or 7, it can't go on here. It would have to go here. If yellow is 6, yellow cannot be 6 and go here. Basically, what I'm trying to say is there any scenario in which yellow can be on one of these 2 squares? And I think the answer is no. Because if it's 6, 7, or 8, no matter what, you're going to have 2 other things on this line. Minimum is 1, 2. That means it has to be a 6, which equals 9, and we know that blue is not 9. That means yellow is here. Oh, is there a problem with blue being 6 here? Let's say this is 1, 2, and 3, which is the necessary numbers for blue to be 6. Well, we know that 1 and 2 have to appear somewhere in here. So is there a scenario in which 1, 2, 3 can be here, and 1 and 2 can be somewhere in here? Yes, there is. Okay, never mind. Okay, I've just noticed another possible thing here, which is these looking at each other. And I'm wondering if we're currently in a scenario in which yellow and blue are allowed to be 6 and 7, and green is allowed to be 8. Because the only valid combination of 3 squares on 6, as we've established so many times in this video, is 1, 2, and 3. Let's assume yellow is 6. And the only valid combination for 7 in a 3-cell, let's call it a cage here, on this line, is 1, 2, and 4. Now, I don't think there's a scenario in which these don't break. Let's just say this is 1, 2, and 4. You can only put 3 in these spots. If you say 4, 1, 2, you can do 1, 2, 3. Oh, God. Yeah, and then you could do 1, 3, and 5 over here. Oh, no, you can't do 1, 3, and 5. Hold on a moment. Okay, I was wrong about this, evidently. But does that create a problem over here? No, because I think if you just switch these around, then you can do 2 here, 1 and 3. Or 1 and 5, yeah. Oh, I know, I found another spot for green. So Green can't go on this line. Obviously, it's not these ones. It can't be this circle because it's not odd. And the green here takes out these squares. So this has to be green, which puts green here as well. Interestingly, that does not put green into box 5 because it could be here. This could be 6-3 or 8-2, or rather 8-1. Totally fine. Oh, but look at this. This is not green. I wonder, is that what we were supposed to find? Wow, really, really cool. So this is now green. However, this is not allowed to be 8. It has to be a 6. So all of our greens are 6s. Look at that. And I'm going to take out the 6 from all the other options here. So if we know that this is 6, then that means this has to be 1-2 pair. This is not allowed to be 1-2. That means these are 1-2 over here. And that makes this either 3 or 5. Oh no, actually it makes it 3. It has to be 3. And this probably does some other stuff for us as well, doesn't it? Oh yeah, where does 6 go in this box? Can't be here or here. Not those two. I could go in this spot though. 6. This could be 6-3. Okay, so it's in one of these two spots. Yeah, it's in what 6 is in one of these two spots and one of these two spots. Actually, we don't even have to use colors there. We can just use numbers. Oh, 6 cannot go here. Oh, sorry. I should have seen that. This is 6. Makes this 6. This is no longer a 1. Oops. Oh, sorry. No, that can be a 1. This is no longer a 3. There we go. We know these 3 numbers, 5, 7, and 8. Where is yellow going in box 5 here? Obviously not here. It's not on the diagonal. It's not seen by that. Oops. So yellow is going to be on the line of this 9. We don't know where. But we know it's either 7 and 2 or 8 and 1, which is the same as this. 7, 2, 8, and 1. Which means, again, we're going to know the remainder of this box because we have 1, 2, 7, 8, 6, and 9. That's 3, 4, and 5. Oh, and that's interesting. It can't be 4. Because, or I should say these two can't be 4. Because it's on the diagonal here. That means this is a single. The 4 can only go here in this box. Oh, and I think we know what this is now. So we have 4, 6, and 9 as solid numbers here. We have 7 and 8 on these two. We have 3 and 5 on these two. Oh, and then we have a 1, 2 here, so this is also a 1, 2. Which I think doesn't tell us much, because this 7, 8 can be 1, 2, 4, 1, 2, 5, or 1, 3, 4. Oh, you know something I am seeing? And I don't know if this is going to result in anything, but it is something I'm seeing. This square right here sees the 1 and 2 from those. And if the only possibilities here are 1, 2, 3, 1, 2, 4, or 1, 3, 4, or sorry, I got those wrong. 1, 2, 4, 1, 2, 5, and 1, 3, 4. That means this square can only be the 3 from 1, 2, or 1, 3, and 4, which it cannot be because of this square. Or it can be the 5 from 1, 2, and 5, or it can be the 4 from 1, 2, and 4. Which means that these are either 1 and 2 or 1 and 3, right? Yeah, 1, 2, 5, 1, 2, 4, or 1, 3, 4. This spot cannot be 1 or 2, so that means this is also 4 or 5, because it's seeing the 1 and 2 from there and the 1 and 2 from there. Oh, does that force this square? Wait a second. So this scenario is the same as this scenario up here, which is that you can do 1, 2, 4, 1, 2, 5, or 1, 3, 4. Well, in all of those scenarios, you need a 1 and a 2 plus a 4. Oh, wait a second. Hold on. With this scenario that we've laid out here, what can go in this square? Well, if this is a 4, then you need 1 and 2, or 1 and 3. And if this is a 5, you need 1 and 2. That means 1, 2, and 3 can go here. But we have a 1, 2 pair here already. So that means this has to be 3. Is that wrong? Have I misunderstood something? I don't think so. I think this is a 3. And if this is a 3, the only combination you're allowed to have here is 1, 3, and 4. You can't put 2 and 4, because that would equal 9. I believe this is 1, 3, 4. I hope I haven't done this wrong. That makes yellow 8, and that makes blue 7. I mean, we're gonna do all this, and we'll see how it shakes out. This whole puzzle is kind of tumbling now, so I'm hoping I haven't done something dramatically wrong. Ah, yes, it appears I have done something dramatically wrong. Because look at this. 5, 6, I need to put a 1 here, and I can't. Okay, I've misunderstood something here. That makes me think I've misunderstood something up here as well, so I'm going to delete this, and then I'm going to come back to this. So this is 1 or 2, which means these 1 and 2s are the same. Oh, yes, I made a critical error assuming that these two are going to be different 1 and 2s, but actually they're going to be the same 1 and 2s. This can absolutely be 1, 2. and it can also be 3 and 4. There's nothing stopping that. The reason we had this scenario up here was because of this 3, seeing it over here. Now, why can't this be 1, 2, I guess is my question. And I think the answer is that it can be. There's nothing stopping this being 1, 2. So I'm not sure how I got to such a dramatic, incorrect answer before. But this can be 1, 2, 3, 4, or 5. Actually, it just can't be 3. Yeah, and the same goes for all of these. 1, 2, 3, 4, 5. Yeah. Okay. Okay, I am feeling like this is the column to look at, though. Even though I just had all those mishaps. Because this cannot be 3, but it can be 1, 2, 4, 5. This is also 1, 2, 3, 4, 5. And this is also 1, 2, 3, 4, 5. And then this is an odd number, which means it's 1, 3, or 5. Now, I'm hazarding a guess here that this actually cannot be 1, because no matter what, we need 1 on these. We need 2 1s on these 6 spaces, and both of those 1s cannot be out of the way of that circle. So this cannot be 1. Now, I believe it can be 3, because this can be 1, 5, 2. Like, this is a valid scenario here. So this is 3, 5. Very interesting. Now, we have 3 5s in these spots. I don't think that really tells us anything. What is kind of interesting is that both 3 and 5 are necessary to make 8 out of these 3 squares, which means there's a 3 or like whatever this is going to end up being on one of these 2 spots. Oh, which means it can't be on that spot. Hold on, let's color this for a second. Orange isn't good. Red. Let's look at the red square. We know it's 3 or 5. Now, we're going to have to use either 3 or 5. Oh, no, you could just use a different number. Don't be stupid. Okay, we know 1 and 2 have to go here. I'm kind of grasping. I've been staring at this for a long time. I'm feeling like I'm missing something obvious here. Because of this, now we know that this is blue. Oh my goodness, we've just found it, haven't we? I think I've just found it. Oh, I've been sitting here staring for a while, but I think I just got it. So, look at yellows, and then tell me, where does yellow have to go in column 1? In this column right here, where does yellow have to go? Well, it can't be in these spots because it sees these yellows. Oh, actually, I guess the better way of displaying this is in box 1, where does yellow have to go? It can't be in any of these, therefore yellow must be in one of these 2. Oops. And if yellow must be in one of these 2, this cannot be yellow. So therefore, this must be yellow. Because this is the only, then what do you do in this box? It can't be these, and it can't be these, and it can't be that. Therefore, this is yellow. And if this is yellow, it is an odd number because of that gray circle that's in there. This is now 7. So all the yellows are 7. Not these 2, because we don't know which one it is. And that changes things quite dramatically, doesn't it? Because now we know that this is 1, 2, and 4. We know that blues are 8s, and that's just going to unlock a lot of stuff for us. This is not 8, 1, it's 2, 7. These are not 8s. This is not 7. And then 8 becomes either 1, 2, 5 or 1, 3, 4. That's actually that's a lot of options there still. But that's okay. We'll get there. Now you can see we have actually we just know that this must be 1 because of this 8, 1 situation. And we are closing in on the puzzle, aren't we? This is now 3 or 5 based on this row. This becomes 3, 5, or 8. And we know that one of those has to be 8. This is an 8. Therefore, this must be 8. And if that's 8, this is 5, 7, 8, 5. Oh, yeah, this whole thing is coming along very smoothly. We've got 3 and 5 over here. And we've got 4 and 8 here. That resolves itself. 5 and 7 here. 3 and 4 here. That gets resolved again. Oh, we're on a roll. 1, 2, 3 up here. Actually, it doesn't really tell us anything. We know that this is now 8 because of this one. That makes this 8. These are 1, 2, 4, and 5. We're almost there. In these 2 spots, we have 2, 4, and 7. And this can only be 2, which resolves these guys. See, this is my least favorite part of Sudoku, is when we're right at the end. And, I don't play these Sudokus to, do the numbers. I do these Sudokus to, figure out the fun puzzles that the setter has set up. So, I'm trying to blast through this, but I've never been good at the actual numbers part of Sudoku. Here we go. 1 and 2 are in these spots, therefore... Oh, I probably could have spotted this a really long time ago, huh? 1 and 2 are here, therefore this must be 4. I think that's an early deduction I could have made. Okay, and we have our final digit here. I believe it is a 5. Looks right to me. There it is. The solution is correct. That took a very long time for me to do. 10,000 solves of this puzzle is kind of nutty. I didn't even realize that many people liked Sudoku. But hey, here we are. Thank you so much for watching. Sorry if you suffered through that in seeing things that I did not see, but such is the way for my monkey brain. And I hope you enjoyed. Farewell.